Greetings to every one of you. So in this video, we are going to discuss another very important concept from data structures and algorithm, that is queues. Queue is a linear list of elements in which deletions can take place at one end called front and insertion can take place at another end called rear. Queue follows the principle first in, first out. The element which enters the queue first and that will exit the queue first. It will come out first. The queue can be represented in two different ways. So one is it can be represented using linear array, or it can also be represented using one-way linked list, that is singly linked list. Consider this is the queue. We have two ends, that is one is rear and another is the front. So through the rear end we can insert the elements, and from the front end we can delete the elements. So initially when the queue is empty, the front value and the rear value both will be that is equal to that is 0. So for example, let us consider the queue does not contain any element. Now we are going to that is entering the values. So first we are inserting a value through this rear end, and a value that is 10 is inserted. So after this, what will happen? The front and the rear points the same location. So the front is 1 and rear is also 1. So this means that now the queue contains that is only one element. So that is the meaning. Suppose if you insert the next element, so the value of this rear will become that is 2. It will come here. Rear will come here. If you are inserting another element, then the rear will move to the next location, that is 3. Similarly, the next element, that is 40. Now the rear is at the 4th location. So this is how we can insert the elements. Let us consider at the time of the insertion, the value of this rear is incremented. Okay. Now let us consider we are going to delete the elements. So let us consider this is the first element which actually inserted first, and only we can delete that element first. So which follows the principle called the first in, first out. So we are going to delete this element. So after deletion, now the front value it was 1, now it will be that is moved to the next location. The front value will be that is incremented by 1. Okay. Similarly, if you delete another element, again the front will move to the next location, that is 3. And deleting the next element. So whenever you are deleting an element from a queue, we have to that is increment our the front pointer. Okay, so this is we have to that is remember. So deletion, at the time of deletion, the value of the front is incremented, but at the time of insertion, the value of rear is incremented. The same thing can also be represented using linked list. So we have front, and in which the starting address, the first node's address is available in the front. So here we have the first node, the 10, that is the value, and this is the address of this particular node. So this part gives the address of the next node. So the 7 at location 7, the second node is available. Similarly, it contains again the link part. So this 8 gives the address of the third node, and this 9 gives the address of the fourth node. So finally we have the value, that is x, it represents the null pointer. So no more nodes available. So the rear contains the value of the address of the last node. Okay. So similarly, we can represent queue in two different ways. That is, one is using the linear array, and another is using the linked list. So let us see this algorithm of this insertion. Insert Q, we have the variables which actually we are going to use in this algorithm: Q, N, front, rear, item. So where N represent the maximum elements we can store, that is the size of the Q. So once if you reaches the rear value reaches this N, we cannot add any more element. So initially we have to check the overflow condition in order to, that is, insert the element. So if rear value is equal to n, that means up to, we have the values here up to this n, that means no space available in order to perform insertion. So if rear is equal to n, write overflow and return. Otherwise, if front is equal to null, this is another thing. The front initially, what is that? The front value is 0. Then set front is equal to 1 and rear is equal to 1. Okay. If front is null, we are going to insert the element. So what we have to do? Initially both the values are 0. We have to, that is, increment the value, that is both the front as well as the rear as 1. So what will happen here? Both the values, that is come to this location 1. So that is the meaning. Else set rear is equal to rear plus 1. So otherwise simply we have a space here and simply here rear value is here. Rear value is here and we are inserting the element. So what will happen? 60 is inserted. So rear is here. So rear value is incremented by 1. Now here the rear will come to the next location, that is 6. So now we want to, that is insert the elements, that is 60. So after moving this, we have to, that is, insert this value. So after moving this, we are inserting the elements, that is 60 into, that is Q of rear. Okay. So the rear position is here now. So in this position, we are inserting the value, that is 60. So initially the value of this rear is incremented. Now it is at the location 6. Now we are we are inserting the value, that is 60. So item, it is stored in the rear position of the queue. Return. So similarly, if you take this deletion algorithm, so here also we have these are the variables we are using. So if front is equal to null, if the front value is equal to null, that means what is it? It does not contain, the queue does not contain any element. Display the message under flow. So there is no element is available in the queue. Okay. If no element is available, we cannot, what is that, perform any, that is, deletion. So no element is available. So front is equal to 0 and automatically rear, if the front is 0, then automatically rear is also 0 only. That being the case, we have to, that is, display the message under flow and return. Take the elements from the queue and store it in the value, that is item. Okay. If front is equal to rear, that means if front is equal to rear, both represent the same value, that is front is equal to rear is equal, for example 1 or 2, whatever it may be. So that means it contain, the queue contain only one element. For example, let us consider we have this value, that is here. This is the element, that is 10. We are deleting this element. So after deletion, so what will happen? This f and r become 0. Okay. So front is equal to rear, then front is equal to null and rear is equal to null. So after this, what we have to do? After deleting the element, we have to make this both the pointer, that is front as 0 and rear is also as 0. Then else, otherwise, you have what's that, the values here. If you are deleting this element, so if you are deleting the element, so after deletion, the 20 is deleted, that is the front is here. So automatically, what's that? Front will be go to, what's that? The next location. So that is the last statement. Set front is equal to front plus 1. Return. So in this video, we have discussed what is queue and how queue can be, that is, represented in a different way, that is linear array as well as the linked list. And also we have seen the algorithm for inserting an element into queue and the algorithm for deleting an element from the queue. Thank you. Keep watching.